Good morning, everybody. We are Giuseppe and Enrico. We are going to show you our analysis and visualization work on the network performance data collected by the Neubot software. So these are the components of our group. Me and Rocco worked on the front-end part using D3.js, while Enrico, that have a lot of experience with developing, work on the data analysis part using Python for the analysis and MongoDB for storage the data. Just 2 words on the network neutrality in order to give you the context to understand our application. The network neutrality is about, you have a situation of network neutrality when all the packets that travel on the internet are treated at the same time, in the same way. So, for example, if there are some congestion situation, the drop packets, there is no discrimination among the drop packets respect to kind of application, senders and destinations nodes. So, Neubot that gathers data in order to investigate the network neutrality is an open source software developed by Simone Basso and inside the Nexa Center for Internet and Society. Nexa is a research center of the Politecnico di Torino that studies internet using a multidisciplinary approach involving engineering, economics, and law in particular. So, after this brief context, Enrico will explain you some issues about the data analysis.
Thank you. So basically, we started with CSV files that was the original data set. So we had one giant CSV file for each month. So more or less 110 megabytes. So 1 year is more than 1 gigabyte of data, basically. And for each month, we have almost 450K entries. So each CSV file was basically like that. And you have here basically the list of all the fields. And we put in red basically the field that we used. So basically we have the IP address of each client, the country of the client, the provider, that is basically the internet provider used by the Neubot client, the download speed, the upload speed, the test name, that is basically in order to discover the network neutrality, we used the differences between the download speed versus the BitTorrent speed. Because as you know, as you can imagine, a lot of provider, maybe, we don't know, we just try to discover this, basically this idea, can filter the BitTorrent protocol in order to avoid, to limit the expression basically of people, because it's just a protocol. You pay for a services, and you should have all the traffic without filtering. That's the basic idea. So in order to basically to estimate the network neutrality, we used this simple formula. So we just estimate the differences between the speed test and the BitTorrent test. And because the idea was to have an index, so we just normalize these differences in order to have numbers between 0 and 1. And actually we discovered on the data set that sometimes the BitTorrent is much more greater than the speed test. So maybe there are some error inside the data set. So this is also a way to understand the data, to find some errors coming from the original data. So this is the process that we use it to analyze the data. So I started to with the academic, let's say, steps. So I started to write the map and the reduce function, and to use the framework that we learn in this course. But at the end, I realized that using MongoDB and Python was very simple to address even this big data data set. So what I did basically was to start from a CSV file. I just filter the file in order to get just the fields that we need. And we also, because in the original file, there was not geographic information. So basically, for each city, I get the latitude and longitude of the information. So I used a previous MongoDB database in order to fetch the data, basically. And after I applied the network neutrality step, so I estimate the network neutrality using the filtered data in MongoDB. So my source of the second step is basically the MongoDB dataset. And the last part was to aggregate by country, because the goal was to show this data from a visualization point of view, so on a map. So basically, we aggregate by country, by city, and by provider. And I just used MongoDB in order to do that. And the result is basically a JSON file that we used for the data visualization part. Just to give you some idea about the performance, in order to, so basically I divided into the 3 steps that I showed in a previous slide. So the first step is elaboration of 450K rows in more or less 3 minutes. So it's very fast. In order to estimate the network neutrality, because basically here we had a problem, in order to estimate the network neutrality, we need 2 different data, the speed test and the BitTorrent test. But these data are spread into all the data set. So that's why we need to aggregate all the IP address and divide it for type. That's why we used the first step in order to collect and aggregate the data. And in order to do that, the Python script took more or less 8 minutes. And the last Python script basically works on a collected number of data, so just 6,000 IP. And it's very fast, less than a minute. And this was not the original, the first time that I tried to execute the script. So the amount of time was greater than that. So after I decided to work with the index feature of MongoDB, and I took this time. So basically I reduced 10 times the time that I need in order to estimate and elaborate the results. So basically, we use MongoDB as MapReduce tools, basically. And some details about the estimation, because the goal was to aggregate the data. So we basically apply a weight mean. So basically, for each network neutrality of each IP address, we count the number of clients. So basically, we did a classic weighted mean in order to be right from a statistical point of view. Okay, and now the visualization part.
Just a few words about visualization before showing you a brief demo. Our basic idea is to show the values of network neutrality at different geographic levels. So this is a world map in which Neubot is installed in all these countries, in all the colored countries. The green value is related to a good situation of network neutrality, while red colors is used for violation of network neutrality according our model. So you can explore the map pointing your attention on a specific country, and every circle represents all the Neubot instances in a specific town. And also in this case, the colors are used in the same way that I explained before. And for each country and for each town, we can also give you some information about the provider that Neubot used for his performance network measurements and our estimated value of network neutrality. So we decided to aggregate the data for country, client provider, and Neubot instances. So, okay. This is the representation of the world, and if you click, for example, on the United States, you can see that in this case, in this graph, you have every section represents a specific provider, and the dimension represents the number of network of Neubot instances that perform measurements. For example, in this case, you can see that for Verizon Online provider, we can have 45 Neubot instances, and the value of the network neutrality is quite great. So you can also explore a specific town, for example, Las Vegas, and you can see that in Las Vegas there are 3 different providers. And we noticed that, for example, AT&T wireless service applies some violation of net neutrality, but we noticed that for mobile providers there is a common situation. In fact, if, for example, we go in Italy, obviously we have to choose different techniques for visualization, because obviously in Italy we have a lot of Neubot instances installed. But for example, if we take Florence town, we can see that also in this case Vodafone, it is a mobile service provider, applies this kind of violation of neutrality. Probably because we have no guarantees yet. The network is not really performed. So, and if you are interested in other countries, we can see the details about the providers. Obviously, in this case, in Gabon, we have a total violation of network neutrality, but obviously we have just 25 Neubot instances, so we have to weight this value for the number of instances installed in this case. Yeah.
Yeah, as you can see, we have also a negative number here, and this is quite strange, because basically that means that if you see the formula that we used, means that basically the BitTorrent is greater than the speed test. So for sure there is some problem here in the data, in the original data. So this is also a good way to just an index that show that something is wrong in the original data, because it cannot be possible that the BitTorrent download is greater, in this case 2 times the speed test. Theoretically speaking, the speed test should be always the same or greater than the BitTorrent the speed. Just a little,
So if you have any comments on that application or have any question about technical issues or something like that, we are here to answer you. Sure. This one is in a host, I believe. And in this case, we have Telecom Italia, but probably we have also different condition for mountains or something like that. I don't know if it's...
Also the number of Neubot
is very low. Yeah. Yeah.
It's also negative. Yeah. I mean,
No,
for sure this is our first approach to, because also we did this work in 3-4 days. So we don't want to pretend to to do some good results from a scientific point of view. But anyway, we just try to, the goal was just to give you a number. So we have a big data, a lot of data. The goal was just to try to find an index that was able to reduce all the information in just one number between 0 and 1. For sure, we have a lot of work to do. We have to redefine the formula because it's very simple. We have to provide a way to clean the data set with the wrong information. But at least was the first approach in order to get an index. That's is the main idea. But also with the helps of Simone, we will try to continue the work in the future to have better results. Yeah.
If I may add a comment, to be more precise, even when you see red, it's not possible to say it's for sure a violation of network neutrality. It's just a warning. You cannot say that because the information on which your visualization is based is poorly application level. So you can just raise a warning. You cannot say for sure there is a violation. To say that, you needed to go more in depth and capture the packets or be inside the network. This was just to clarify the scope of the data that is visualized. Thank you.
Giuseppe, can you please show maybe more red the European countries like Turkey, maybe Portugal, Turkey, and Iceland?
In this case, we have only 2 Neubot instances, so it's yeah. Also Turkey. Okay. Manisa and Istanbul.
This is just 1 month of data.
Yeah, just 1 month.
We have almost 2 years, 1 year and a half of data. So it would be nice to execute the script, because all the script that I showed are basically you have parameters, so you can execute by command line. You can specify the file of input, and that's it. So it's just a way to, we need to execute and store all the information on MongoDB so we can filter and produce global maps for almost 2 years of data that for sure will be more interesting.
Okay, another more comment on that. I think what they did may be very useful for the Neubot project. For example, take the case of Portugal or Turkey. You see that we have a possible warning and a low number of instances. So a country where you can, which you can target to have more instances installed. And also, in case of warning, you can imagine that Neubot is announced to run more in-depth tests, trying to investigate what actually is going on and what is the cause of the warning. This was just to stress once more that what they did is also something that fits with the path of the project.
Maybe I missed just a really fast question. What does it mean, the size of the circle in each?
The size should show the number of instances on
Okay.
there, but obviously we have also to think about for choice a better scale, because in this case you have not a precise dimension of SQL related to the Neubot instances, but just to show in a large point of view this thing. Because in some cases, for example, in Italy, in Turin, we have a lot of Neubot instances because we have the Nexa Center here. So in that case, we have to choose different dimension for cycles. So.
I have a short proposal for your visualization. Maybe you should concentrate in visualizing only the statistically significant data. So in this case, you have a lot of points on your maps with 1, 2 instances that are not really interested to be seen. What we want to see is something that will lead to some conclusions about network neutrality when we present, and maybe not in the case of Turkey, where you have a big red circle, which of course takes attention, but it's not significantly important to be shown. But again, so as you say, in Turin, that you have a lot of data, then you can say a story of what is the situation of network neutrality. Simple suggestion.
Yeah, actually, as I said, it's just we're just to run the script. The platform is in place, so if we run the script and we put the data in MongoDB, for sure we will increase the number of. But for sure, we have to remove not significant data.
Of course, keep all this project as, I mean, work in progress, definitely. This is not a end at the end. And I hope that many of these projects will continue in the next days, next weeks, trying to have, more precise or more presentable or useful or whatever situation. Thanks.